Hello and welcome to this video where we're going to talk about stealth and why I think it's a concept that's soon going to be outdated. First, stealth is a set of methods that allows equipment to avoid being detected. Whether it's staying discreet against radars, emitting as little heat as possible that could be detected by infrared sensors, or having reduced electromagnetic radiation. Today, we're mainly going to talk about stealth against radars. Many analysts, including myself, believe we've placed too much importance on this characteristic, and that the advantage we get from a stealth aircraft will become less and less relevant as radars adapt and new detection methods gradually develop. While the missions of a stealth aircraft can increasingly often be carried out by other means, the worst part is a stealth aircraft will keep facing more operational constraints, even though stealth is no longer always guaranteed. And all that for a cost that will be exponential. So we need to talk about it. First, we need to define what we mean by stealth. Classic stealth is known as passive stealth. It aims to reduce an aircraft's radar cross-section using two main methods. First, we design the airframe, with angles and edges that reflect waves differently than the radar that illuminated us. This is especially clear on the F-117, the first aircraft designed from the outset to be stealthy. On top of the fuselage, they apply absorbing coatings that can cost tens of thousands of dollars per square meter. And thanks to these methods, aircraft can get as close as possible to their target without being detected in order to deliver their weapons. We already have two early examples in the field. Obviously, the stealth bomber F-117, which was developed from the mid-1970s and was revealed at the end of the 1980s, as well as the strategic bomber B-2S Spirit, which was developed at the very end of the Cold War, since its first flight was in 1989. So, you see, we have two planes that are very unique because of their shape, but what we don't see are their costs. The F-117 program cost about $15 billion plus $100 million to build each aircraft. The B-2 program costs $53 billion in 2025 dollars, with each plane adding $737 million, an enormous sum compared to other planes of that era. For example, getting an F-117 outside the program cost 3 times more than an F-16, which was $35 million at the time. But the difference is also in operating costs. The F-16 cost about $7,000 per flight hour then. That's compared to about $40,000 per flight hour for the F-117 and $135,000 for the B-2, based on 2010 figures. The craziest part is these planes cost at least 3 times more to buy and 15 times more to operate. Well, at the time, it seemed like something economical because stealth had also been identified and understood as a real force multiplier. And to understand, you also have to start from the feedback. The United States had carried out, for example, this mission documented by the United States Naval Institute proceedings. It explains that a single raid on an Iraqi air defense site required no less than 4 F-18s, to which 3 BQM-74 target drones had to be added to lure the Iraqi air defense. This allowed 4 F-4Gs to destroy the radars with their dedicated missiles. Meanwhile, 17 other F-18S surrounded the area and were to destroy any possible surface-to-air missile launchers, with help from 5 EA-18s and 6 B-Prowler electronic warfare aircraft, which can jam radars. All of this was illuminated by airborne warning and control system and accompanied by refueling aircraft. All that effort just so 4 A-6 and 4 Tornadoes could bomb their designated target. Do you see this group of aircraft? The other option was to have 2 or 3 F-117S carry out these missions stealthily with no need to protect them, simply because they couldn't be detected at the time. So all the general staffs were led to believe that stealth offered a kind of invulnerability. This would save money by needing just 3 bombers instead of around 20 aircraft. So it saves money despite operating costs being much higher, except that today this concept of near invulnerability of stealth is no longer guaranteed at all. That's why I need to explain a few technical points to you. First, stealth aircraft are harder to detect because they are designed to counter radars. Those were about the only ones available then, especially in the Eastern Bloc. That means there were frequency bands being used called the LSC or X bands. But when you use frequency bands called very high frequency or even ultra high frequency, you get closer to what's called the resonance regime. That means the wavelength of the frequency emitted by the radar is the same size, the same length as the object you're trying to detect. That means the airplane, and in that case, the wave will come back and a stealth aircraft is no longer stealthy. That's what the Serbs used in 1999 with the P-18 radar, which operates in the very high frequency band. That radar let them track the F-117 stealth bomber's route, since it usually followed the same path daily. Then, once the route had been identified, they placed a standard air defense system right along that path. And that was enough to detect the F-117 during the few seconds when it opened its bomb base to drop its bombs, which at the time allowed it to be shot down. And so more recently, that's also why the Iranian very high-frequency radars, the Gadir type, were the first to be bombed as a priority by Israel in June 2025. This is what allowed the American B-2S to come and carry out operations. The bombings required flying almost directly over targets to drop the guided bomb unit, 57 bomb. However, other technologies, including trans-oriental radars, now provide similar detection results. They operate in ranges that are only 5 to 30 MHz, which are so low that they bounce off the upper layers of the atmosphere to achieve detection ranges of up to 3,000 kilometers. That's how the French radar Nostradamus was the first to provide proof that stealth aircraft could be detected in these frequency ranges. And besides, it's a radar that has just been reactivated, and we can also mention it. The Russian NEBOM radars, as well as the Chinese JY-27, operate in the same frequency bands. You have to understand that this is strategic detection, meaning we know that something is flying and coming toward us. But this isn't tactical level detection for firing, and that's why we've seen the rapid rise of radars integrating multiband networks that combine these different capabilities. And that's not even all, because there's another absolutely brilliant technology called multi-static radar. The radar's transmitter and receiver are now in different locations. Since stealth aircraft are designed to reflect the waves toward a different place than where the transmitter is located, well, you just have to scatter the sensors far from the transmitter, so you'll always have different sensors that will be able to detect the aircraft. You might say that as a result, it's possible to destroy these radars, destroy the transmitter, since they're emitting a wave which reveals their presence. And that's what makes it possible to fire missiles like the American air-to-ground missile, 88, the KH-31P, or the Spire electronic warfare from MBDA. They will trace the radar's emission source, enabling its destruction. Except that, as a result, there's yet another solution called passive radars. In this case, there is no transmitter at all. We're just going to use a network of sensors that will receive the waves coming back from the sky, like very high frequency radio, the telephone, and so on. Normally, these are waves that scatter in the atmosphere, but if there's a plane, even a stealth one flying overhead, the waves will come back down, and that will allow us to detect them, even if they're stealth aircraft. They're effective enough for drone detection in cities, as shown by Ensalt's TwinVis system. They have published demonstrations for regional coverage and will soon be certified for German civil aviation and air traffic control. So, as you understand, airplanes are optimized for only one frequency band, and in fact they are quite detectable on other frequency bands. Here you can see a comparison of the F-35's wave reflection based on radar wavelength. And the problem is that even though we know very well that the F-35 stealth will decrease over time, we will always face the F-35's original constraints set to make it stealthy on certain frequency bands, bands that might not even be usable in the future. Let me remind you, this aircraft will fly until 2080 with constraints that will always be those set in the late 1990s. First, we have to remember that an aircraft is still the sum of the compromises that were made at the time of its design. That means they will affect its performance. Operational for decades. For example, compromises were needed on the shapes to deflect waves, but this reduced the aircraft's aerodynamic performance. It's obvious on the F-117, but if we focus on the F-35, we know, for example, that the shape and size of its nose have been reduced. Except now, we know that it's too small to fit current radars and technologies, or even the ones that are coming soon. Similarly, the shape of the air intakes was designed to prevent a direct line of sight to the compressors where radar waves could bounce off. But this shape reduces the size of the air intake and therefore the amount of air that will be ingested. Pilots must limit electronics use in some conditions since less air reduces performance. Possibility to cool systems like the batteries or the radar while the engine can't generate enough electricity for the systems planned on the aircraft, such as offensive electronic warfare. And it's even harder to imagine integrating future weapons, especially laser weapons, which are still frequently mentioned. So the second problem with stealth is also that stealth requirements complicate some actions that are normally simple. For example, the coating can't withstand heat, which prevents prolonged flight at high speeds, just like the blisters that formed on the F-35. And that's one of the reasons why the United States didn't develop supercruise capability on the aircraft, unlike other planes like the Eurofighter or the Rafale. Whereas supercruise means the ability to fly above Mach 1 without using afterburners. It's a criterion for fifth-generation aircraft according to the official American classification, so in the United States classification the F-35 doesn't meet all the criteria of a fifth-generation aircraft, which is still pretty amazing. There's also a third problem for stealth aviation. It's very fragile and must be treated with extreme care, with hangars that have a controlled environment in order to maintain precise atmospheric pressure and humidity. Here, for example, is the B-2's temporary pressurized deployment hangar. There are always long cleaning procedures after each flight to ensure no dead flies or grains of sand remain on the aircraft and damage its coating. Similarly, an aircraft flying over the sea becomes salty, accelerating the degradation of its stealth coating. This is even more complex for a naval aircraft like the F-35C. If there's an oil stain on the fuselage, it's a disaster. But in any case, the coating deteriorates more quickly when it's exposed to the sun or rain. Here, you're seeing images of an F-35A in Japan that show imperfections ruining its stealth, and which are certainly caused by the surrounding humidity. Because when these planes are not kept in optimal storage conditions, for example during operational deployments, well, you have to reapply this stealth coating even more frequently, which further reduces the availability of the aircraft. Maintenance of the stealth coating is frequent, as I mentioned. In fact, we can say that stealth imposes a disproportionate burden and that it has become the main maintenance task for all stealth aircraft. And I'll give you some figures that were directly shared by the United States of America about the F-22 stealth accounts for a third of the total maintenance time on the B-2. It takes 124 hours of maintenance for every hour of flight. Over half of that workload involves stealth, while for the F-35 stealth makes up 10 to 25% of maintenance, depending on configuration. And I'm providing all the sources for you of this video. So when there's an incident that affects the stealth characteristics of the aircraft, that's just crazy. For example, the cost to repair the F-22, which made a belly landing in 2012, was $30 million. The price was actually $100 million. The Korean F-35 made a belly landing in 2022 after ingesting a bird and required replacement of 300 components, including engine parts. That means that repairing the plane costs more than a new one, so obviously they simply decided to abandon it. So even if tomorrow we consider that the F-35 stealth is obsolete, this complex and expensive maintenance will still be mandatory, while the plane's operational capabilities might not necessarily be as guaranteed. And that's not all, because up until now, I've only talked to you about the radars that could detect the plane. Except that there are more and more ways to detect the aircraft through other means. For example, with what we call the infrared search, and track a super infrared camera which can detect, identify and lock onto a target at more than 50 kilometers when it's coming toward us. Thus, the engine's heat is concealed, but if the plane isn't completely facing the sensor, the proven detection range can even reach 110 kilometers for an F-22 and even 150 kilometers for a B-2, and we're talking about planes that are also highly optimized in terms of heat signature since the nozzles are partially hidden. That's definitely not true for the F-35, which produces much more heat than the F-22. So you could suggest using an electric plane that doesn't emit heat. Except that when a plane is flying, there's a kind of overpressure that forms at the front of the wing. This overpressure, along with the friction of the air on the wing, that will emit infrared radiation at a very specific wavelength. Even a stealth plane with electric heatless propulsion could still be detected this way. And so now I come to this question, but actually what is it for? A stealth plane? Why do we need one? It was designed as an aircraft able to penetrate contested environments, with the goal of being able to bomb a site despite the presence of air defenses, or to approach and destroy enemy radars, clearing the sky for other aircraft. The United States Air Force claims its F-35 can approach within 40 kilometers of the S-400 air defense system undetected, whereas an F-15 would be detected nearly 10 times farther away. In the 1990s design of the F-35, the goal was to handle targets using just a glide bomb, except that missile performance has increased much faster than the effectiveness of stealth, to the point that even the Ukrainians are able to destroy S-400 systems with Neptune surface-to-surface missiles that they developed on their own. They even managed to damage the S-500 system as radar in Crimea. The Voronezh radar can detect potential ballistic missiles aimed at Moscow. All this with simple long-range kamikaze drones. While the French Stealth Scout missiles have been able to destroy advanced air defense systems. For example, in Libya during France's Operation Harmattan, the Air Force held several exercises where Rafales and cruise missiles targeted S-300 air defense systems, such as in 2005 in Slovakia and 2013 in Greece, and succeeded each time. They were able, obviously in Ukraine, when they were launched by Sukhoi 24 fighters dating from the Soviet era, they were able to penetrate all Russian air defenses, hitting command posts, the headquarters of the Black Sea Fleet, ammunition depots, arms factories, submarines at the dock, ships in the port. All this while entering the Russian protection bubble, once considered the world's most effective before the war. Given all this, we can still ask, what's the point? A stealth aircraft, if the most crucial missions it was developed for, can be carried out safely by missiles that stay far away, launched by much more basic Soviet aircraft, which are much cheaper to operate. And besides, we can observe, unchanged regarding air superiority in combat, overall, a plane that uses its radar is more likely to be detected, so we stay discreet for as long as possible. And air combat increasingly relies on powerful radars staying behind or on the infrared search and track sensors of the planes. In that case, stealth has no effect. Also, only the latest F-22 update, which is just starting, will add an infrared search and track. That means, in theory, by staying radar stealthy, any plane equipped with an infrared search and track, whether it's a Sukhoi 35 or a Gripen, will be able to spot the F-22 before it detects us. As you can see, stealth isn't what it used to be. Both because there are these new radars and sensors that use thermal signatures. Meanwhile, the tactical advantage of the concept is decreasing due to increasingly effective and abordable long-range missiles. So, let's be clear, stealth is not useless, and planes are still harder to detect and engage with traditional means. Stealth is now a costly, fragile advantage that can be undone by coordinating various sensors. So specifically, if I show you a full kill chain, first I have a radar. Trans-Horizon detects stealth aircraft approach axis over 2,000 kilometers away and also from 400 to 500 kilometers. A very high-frequency radar can define real tracks, allowing infrared sensors to lock onto targets. Whether it's an infrared search and track on a plane or a ship, or even cooled sensors on long wavelengths, infrared sensors. These systems can be placed on a mast on the ground, even without full deployment. When I mentioned sensor coordination, I've already discussed world-leading data fusion. For example, on the Rafale, all aircraft sensors will be used to obtain a clear tactical situation and to track the same target in different ways. For example, the infrared search and track, sometimes aided by radar if a target goes behind a cloud, or by using another aircraft's infrared search and track. Rafale's development extends further and includes the multi-static radar concepts I mentioned earlier. That means if a Rafale or a combat drone turns on its radar, all the other Rafales will pick up a little bit of that echo. And even if it's a stealth aircraft in front, the accumulation of these micro echoes will be added together to reconstruct the track. Here, you can see a statement from Dassault on the screen that suggests this capability is coming, though it's not fully available yet. Public and revealed. So what matters today for an aircraft is its ability to use passive sensors and to share information without being detected, and to have missiles with a range that will give it an advantage over its opponent. And so stealth can be useful against countries that are poorly equipped, but it absolutely shouldn't be an end in itself. And you have to find the right balance between stealth and the overall performance of the aircraft. Unfortunately, the United States of America focused too much on stealth, sacrificing operational performance. Plus the aircraft's high operating costs and low availability. They prevent acquiring a fleet a size that would be large enough to face a real war. Stealth aircraft matter mainly for wealthy or warring nations with diverse fleets, like the United States of America, obviously, Israel, South Korea, or even Greece, which chose to get a handful of F-35s complemented by a larger fleet of Rafales. But in any case, it will remain totally inappropriate to burden ourselves with a stealth capability that will make the aircraft worse and less efficient. in 99.9% of the missions it will have to carry out in its lifetime. And knowing that almost all of the 0.1% of missions where stealth is currently an advantage can be carried out by long-range missiles, as the Ukrainians show us every day. Also, this stealth advantage for the 0.1% is likely short-lived. So, as we forget one, I'm not saying we shouldn't have stealth aircraft, I'm saying they should never be the core of a combat fleet. It's good to see piloted aircraft working with stealth combat drones, able to handle that 1% of missions like the drone set to accompany Rafael by 2035 or Eurofighter's recently announced project. For example, in Australia, Boeing developed the local Royal Wingman, but in any case, it's absolutely necessary to develop 6th generation technologies, including stealth, for these future aircraft. It will be necessary to combine these technologies on a sensor network across many low-cost drones, costing a few €1,000s each, flying in swarms ahead of the front line to detect enemy aircraft. And that's also why, personally, I'm less and less enthusiastic about the concept of manned 6th generation aircraft. Like the next generation fighter from the Future Combat Air System program, which are the backbone of future aviation, because in the end, it's the sensors, connectivity and missile effectiveness that matter. A stealth drone can carry it and is easier to replace than a piloted aircraft when obsolete. All of this could be coordinated by rear aircraft such as two-seater Rafales, airborne warning and control system command planes, or A330 multi-role tanker transport refueling aircraft. Or the A400M, now viewed more as a drone carrier with growing emphasis on its command platform role. So you see that the debate is still clearly very open today. Public opinion mostly believes that stealth is the ultimate feature of an aircraft, including for 6th generation aircraft. And that's a statement that is completely false, especially since the doctrines of air power, when the next generation fighter will be available in the 2040s, they're unclear. We don't know what technologies or threats we'll face. We're focusing solely on a 6th generation piloted aircraft, sacrificing everything for strong stealth. I think it's a bad idea, and more people think so too. So there you go. I hope you enjoyed this video. If you're interested in stealth, my friend Bruno has started a 4-part video series on the topic, and we coordinated the timing of this video. Feel free to visit his channel and watch his videos too. You won't regret it. In any case, I hope you enjoyed it, and I'll see you very soon.